Geometry. Welcome to our next unit on triangles. In this first section, TC1 will be about the angles on triangles and how we classify triangles by both sides and by angles. So first up, classifying triangles by sides, we can look at if they all have the same sides. If the sides are all of equal measure, they're all congruent, then we say that that's equilateral. So three congruent sides. Notice the markings on the segments. Same number of marks means those are equal measure. Isosceles triangles have two congruent sides. And scalene triangles have none of their sides the same length. All three sides are different lengths. All sides different lengths. Okay. Now if we're classifying these triangles by how big the angles are, if all three angles are acute, then it is an acute triangle. All three angles are acute. For a right triangle, all it takes is for one right angle. And for an obtuse triangle, all it takes is to have one obtuse angle. Okay, one obtuse angle. Okay. Now, we're going to find something else out about obtuse and right triangles on the next page. For now, we're going to take a look at the triangle sum theorem, which says something about the interior angles in a triangle. What the triangle sum theorem says is that the three interior angles add up to 180 degrees. So the interior angles on any triangle add up to 180 degrees. So for this triangle, that would be this A, this B, and this C. A plus B plus C add up to 180 degrees. Now, we can actually prove that this is the case using parallel lines. If we draw a line parallel to one of the sides, so if this line here is parallel to this side, we have a couple of the angle pairs that we had back from when we talked about parallel lines. Notice this angle A up here and this angle A down here. Those are alternate interior angles. This angle B is the angle B from this triangle, but it's also part of this straight angle. And this angle C and this angle C are the same because those are alternate interior angles. So how we could prove that the interior angles theorem, or the triangle sum theorem, is true is by saying that, hey, these three angles here, this A, B, and C, add up to 180. And so let's start with that. So A plus B plus C. And we're going to actually call these other angles here. I'm going to actually name these vertices. So this is angle B, this is angle A, and this is angle C. And I'm going to scratch out those A's there so that we aren't assuming that those are already the same measure. So we're going to say that A, B, and C add up to 180. Why? Well, those three angles form a straight angle, and straight angles are 180 degrees. So as far as proof goes, if we're going to prove this in two columns, we could say A plus B plus C equals 180 because they form a straight angle. Then we can also say that since that's a straight angle, and we have this line here is parallel to AC, we could say that this little a is equal to the measure of angle A. So little a is equal to the measure of angle A, because those are alternate interior angles. We have angle C is actually before we get to C, let's talk about B. So angle B and that little b are equal. Those are equal because of the reflexive property. When something is equal to itself, that is the reflexive property, reflexive. And then we can say that angle C, or that little c, is equal to the measure of angle C. Also because of the alternate interior angles theorem, alternate interior. And now that we have A is equal to the angle A, B is equal to angle B, C is equal to angle C, we could replace those values in the 180-degree equation. We can say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees by the substitution property. We're substituting those values into that original equation. Substitution. Okay. And so we've shown that this is true for, since we did this general, we did this for any triangle with those labels. That's always true regardless of the triangle. A, B, and C add up to 180 degrees. Pretty cool. We will be returning to some more proofs later on in this unit, talking about how to show triangles are congruent to one another, but we can use proofs to justify any of the theorems that we come across. So let's practice using the triangle sum theorem and using our classification criteria. So to find a missing angle measure, we're going to write that those angles add up to 180. So we can add the 25s and subtract to get 130. So we have a 130-degree angle. This is an obtuse triangle by classifying it by its angles. Okay, so this one is obtuse. And classifying it by its sides, if we have two angles that are congruent, we're also going to have two sides that are congruent. And this is a property of isosceles triangles, and we'll talk more about how the angles and sides relate to one another in the next section. For now, it's enough to know that if the angles are the same, there's going to be two sides that are the same as well. So classifying by its sides, two sides are the same, that is isosceles. In this next one, we have a 90-degree angle, a 45-degree angle, and y. So y plus 90 plus 45 equals 180. Add the like terms to get 135, and then subtract to find that y is 45. So once again, we have 45-degree angles, so we're also going to have two sides that are congruent. So this is isosceles, and we actually could classify it right away. If it has a right angle, it's a right triangle. So this is a right and isosceles triangle. Right isosceles. This one here, we have a K, we have a 60, we have a 60. Now, before you go saying, all right, I see two angles that are the same, this is isosceles, well, let's find out what K is first. We don't want to jump to conclusions. So K plus 120 equals 180. Subtract to find that K is also 60. So this is an equilateral triangle. Has three angles that are the same. It's also going to have three sides that are the same. Equilateral, and since all the angles are acute, it would be acute. Now we're also, another word that we didn't write on the front page, but we'll get into in a future section more about equilateral triangles, is we can also call this equiangular. Equiangular. So for today, we'll focus on equilateral and acute, but we'll also refer to this as equiangular in the future. Here we have an R and a 125 and a 35. They add up to 180. So R plus 125 plus 35 is 160. And then subtract to find 20. So R is 20. Has an obtuse angle, so this is an obtuse triangle. And if all three angles are different sizes, then all three sides will also be different sizes, which makes this one a scalene triangle. Scalene. And then this last one here, we have a 90 and an X and a 30. Those will add up to 180. And we can combine our like terms and then subtract to find X is 60. So once again, all three angles different measures, so all three sides will also be different measures. That will make this one scalene and right. We have a 90-degree angle, and it is a right and scalene triangle. Okay. Now, beyond what we can do with the interior angles, we can also refer to what's called an exterior angle. Exterior angle. Exterior. This is an exterior angle. And there actually is an exterior angle theorem. Exterior angle theorem that says something about the measure of that angle. Now, these two angles over here are both interior angles. More specifically, they are not next to that exterior angle. So what makes an angle exterior is it is a linear pair with one of the interior angles. So linear pair with the exterior. So this angle here that is adjacent to that exterior angle is a linear pair with that exterior angle. Now, because of that, linear pairs, remember, back from when we talked about angles, linear pairs were supplementary. They add up to 180. Now this angle here also adds with those other two interior angles to add up to 180, which would mean if these add with that angle to get 180, and this adds with that to get 180, well then angle D and A plus B would have to be the same measure. So these two angles over here, we're going to refer to those as the non-adjacent interior angles. The non-adjacent interior angles, their measures add up to that exterior angle. So let's write this in words. So an exterior angle equals the sum of the two non-adjacent interior angles. Okay? An exterior angle equals the sum of the two non-adjacent interior angles. So as an equation, that's just going to look like this. D equals A plus B. Okay? The sum of the two non-adjacent interior angles, add the two non-adjacent interior angles together, is equal to that one exterior angle. So then we don't have to bother with the adds up to 180. We have these two things equal to each other. It's kind of cool. Now, another thing we can say about the exterior angles are, they also have a total, just like the interior angles do, but they don't add up to 180, they add up to 360. Exterior angles, we'll call this the exterior angle sum theorem. Exterior angle sum. The three exterior angles, and remember, the exterior angles are the ones that are linear pairs with those interior angles. The three exterior angles add up to 360 degrees. So in this case, that would be X and Y and Z add up to 360 for the equation. We can easily prove that to ourselves by drawing lines parallel, drawing a line parallel to this opposite side over here. So kind of like we did with proving the interior angles add up to 180. But in this case, you can see if this is parallel to this side here, then Y would be up there as well, because those are corresponding angles. And Z corresponds to this angle here. So those three angles put together form a complete circle. They would add up to 360 degrees. Pretty cool. So to try each of those theorems out, so make sure we're in focus here. Okay. This single exterior angle is equal to the sum of the two non-adjacent interior angles. So 2x plus 10 is equal to x plus 65. The x and the 65 add together to equal the same total as that 2x plus 10. So we can subtract x, we can subtract 10 to find that x is 55. For these ones, the measure of the exterior angles of a triangle are 3x, 8x, and 9x. So if we have all three exterior angles, we can say that those three exterior angles add up to 360 degrees. Find the measure of the largest exterior angle. Well, let's first find x, and then we can plug it back into that 9x expression. So 3x plus 8x is 11x, plus 9x is 20x. And then divide to find that we get x is 18. So if x is 18, then 9x, or 9 times 18, will be our largest angle. 9 times 18, 9 times 10 is 90, 9 times 8 is 72, 90 plus 72 is 162. So our biggest angle, our biggest exterior angle is 162. Okay. And then let's wrap things up on this section with a rapid fire of some theorems that are direct results of the other theorems. So when we have a result that's a direct result from a theorem, it's usually called a corollary. The two angles of one triangle, or if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. And that makes sense if we think about, we have two triangles, they have two angles that are the same, so their third angles would have to be the same as well, because they have the same total, right? Each angle of an equilateral triangle has a measure of, and we can answer that if we look back at our previous page here, 60, 60, and 60. If all three angles are the same size on an equilateral triangle, they all have to be 60. Right? If we have 180 degrees divided by three equal pieces, divided into three equal pieces, we get 60. So an equilateral triangle has angles that measure 60 degrees. In a triangle, there can be at most one right angle or one obtuse angle. And knowing the triangle sum theorem, since they have to add up to 180, if we have a right angle, 90 degrees, well, if either of the other angles is 90, then we're already up to 180 without any room for the third angle. So that doesn't work. And for an obtuse angle, if something's bigger than 90, well, same rationale. You're not going to be able to get a total of 180 if you have more than one of either of those. The two acute angles of a right triangle are, and this is a really important result, the acute angles in a right triangle, since they can't be right or obtuse, they will both be acute. The two acute angles are acute, but they're also, if we think about having a 90 plus, I'll call this A and this one B, a 90 plus A plus B equals 180. We could start, instead of combining any like terms, we could start by subtracting the 90 from both sides and find that A plus B, regardless of the right triangle, A plus B have to be equal to 90. So we're going to say that they are complementary. Okay? So A plus B, the acute angles in a right triangle, are complementary. They add up to 90. This is a really important result because it lets us make our equations simpler. We don't have to start off with they all add up to 180. We can just start off with the two acute angles add up to 90. We can leave out that 90-degree angle. And when we get into certain branches of trigonometry, that's going to be, we're going to use it in almost every problem. So these last four problems here, we're going to do these together as an exercise in class, and I will talk to you then. Bye for now.